Hey guys, hope you are doing good. This is a live recording of my Python sessions. In this video, I'm talking about different types of function arguments, some advanced function concepts, and Lambda function in Python. And don't forget to watch my last video on function and scopes. Link is in description. Please like and subscribe my channel and share as much as possible. So let's learn together. Just give 1 minute. Okay, guys. So in last session, we covered function and we covered scopes, uh, variable scopes, and all those things. In this session, first we'll cover function arguments. So how means what all are the ways we can pass an argument to a function? Okay, and what all things we need to take care of while passing any argument. So there is some basic, we'll read it out. So arguments are passed by automatically assigning objects to local variable names. Okay. Can you guys go on mute? So arguments are passed by automatically assigning objects to a local variable names. Means when we are passing any argument into a function, so that argument will become a local variable inside that function. If we are not using non-local or global keywords, it will be a local variable inside a function. Okay. Assigning to argument name inside a function does not affect the caller. I think we saw in last session that if we pass any variable, means if we assign any value, it will not reflect to caller. Okay. And changing a mutable object in function may impact the caller. Okay. So we'll see these 2 points today also. So immutable arguments are effectively passed by value, and mutable are effectively passed by pointer. As means in other languages we use pointer, so it's passed by pointer. So let's write a small function. Okay, and we'll take one parameter and just will assign some value. Okay, and now we have one p equals to 88, and we pass a p. Okay, and let's print it here. Print this p. Okay. Okay. So you will see 88 is printed. Means we passed b to this function f. We tried to change the value, and now when we printed outside, means when this function returned and we printed this b, it's still 88, because this, when we are passing this parameter, so this a will become a local of this. When we are going to assign it, it will become a local variable. And if we print it here, okay, so you will see first it printed a equals a, so which is 88, we passed. Then we assigned a to 99, and once this return, still b is 88. 88, then we assigned value. So when we assign this value, at that time this will become a local variable. Means when we are passing any value, we can refer that value, but we cannot because it will become a local into this function, and when we are updating it, it will update the local instance of this a, and this will not reflect outside of the function. Okay, so this is the first line. This line inside the function does not affect caller. Okay. Now, when arguments are passed mutable objects, okay, when we pass any mutable object like list and dictionary, we also need to be aware that in place changes to objects may live after function exits. Okay, let's see this also. So it's like one function, and let's just do this. What it is doing is we are having li as an argument passed into this function, and this k, we are multiplying each element of this argument and storing it. So like this, it's k and l, and print this. So you will see we passed a list 1, 2, 3, 4, and one value k, which is 2, and we are doing multiplication. So this list is changed down. Okay, so it's changing. Means in place it is changing, and we can verify this if we print some value. The address of this list we are passing inside, and we print this outside of the function. Let's see. So you will see we have both, means we have the same list. Okay, because it's mutable, so it is changing. Let's check what is the value of li0 here, and outside this function, what is the, means the address of the first element we are checking now. What is this change? It's invalid syntax. What is invalid here? Okay, let's come back. So you will see both are same. Okay, so both are same, just the values at this position is updated. So if we are passing any mutable object to a function, it can be updated, and that updation will reflect outside, means whoever is calling. I hope this is clear till now. Now let's see how we return from a function. I think we already saw in last session, but once again I'll cover it quickly. We have a function. Okay, yes, I just named it multiple. Okay, and I'm just passing x and l and getting are returning that from the function. You will see we can return multiple objects from a function. Okay, so we already saw this in last session also. Okay, we can get that, and whatever is returned, it is returned as a tuple. So we can confirm it by printing this. Okay, you will see function returns a tuple. When we use this kind of statements, when we are giving two variables and function is returning two values, it will unpack it here and assign x to x and l. Okay, so always this function will return a tuple, and at this, when it is returning, it will unpack that those return objects and assign. Okay, so let's see what are the argument matching basics. Is how Python identifies arguments. So we can have these type of arguments: positional, keywords, default, VRs. Again, VRs. This is VR collecting. This is unpacking. We'll see what it is. Keyword only. So positional means match from left to right. Whatever we right till now we were passing, these all are positional. Okay, means when we are passing any value, so if we want to pass x here, so this is position based. Means we know that this function will take first value as x, second value as y. So always we have to pass x first and y second. So this is positional. Keywords, we'll see what keywords and all these are. Just I'm introducing that these are the types of arguments we can pass into the function. Okay. So let's see. This is a chart. Just I am adding it here in this document. We'll see how all these function. This is a chart, means how we pass a argument when we call a function and how we write a definition. So this is one place for all these things, which we are going to discuss later on. Okay, so positional we already saw. So we'll start with keyword. Let's say we have this function a, b, and c. Okay, and it will just print those values. Let's call it 1, 2, 3. Okay, like this. We call this function. It will print 1, 2, 3. Okay, it's fine. But there is another way, which is keyword way. We can call it like this. I'll change it. Still it is printing. So this is a keyword way. Okay, means we are telling Python that the value of a is 2. Now we can also write it like c equals to 4, a equals to 2, If we write like this, still it will work fine, because in this line we are passing values as a position, means one, we want to assign one in A, so we are passing one first, then two, then three. But this is a same way, and in this way we are saying C equals to 4, means now whatever at whatever position this C is in this definition, I don't care, you find that and you assign the value 4 to C. Okay, so like this way, in this way Python will know that C is 4. Python has to assign 4 to C, 2 to A, 3 to B. So this is the benefit of keyword based, means you need not to remember the sequence or position of your variable. Okay. So keywords typically have two roles in Python. First, they make your call a bit more self-documenting, because from this call you will not know that one is to which variable. Means let's say it is one ABC, but if you have three different parameters, you have given some name. So from this call you will not know what value is going to assign to which argument. For that you will have to see the function definition and then you will get to know. But in this way, seeing this function call, you will get to know, okay, what value, means which field has what value. Okay. And second major use of keyword occurs in conjunction with default. So we'll see how. I hope this is clear till now about this keyword. Pretty straightforward. Any question you can ask? We'll see what default arguments are.
Dheeraj,
Yeah. Yes.
I have one small question.
Yes.
See, in functions, we can pass if I pass only two values instead of three,
Okay.
it will show error, right?
Yeah, right.
Is there any way that I cannot only pass two values, that it will take the third value as like already declared C equals to 0 if I
Yeah,
declare?
that's what I'm going to tell here. Default. Okay, we have this default. So in this default, what we do, we predefine the value. Means we give some value to the argument, and so now these arguments are optional to call. Okay, so if I call it like this will succeed. Okay, and see 1 2 3. 1 I passed as a positional, B I did not pass, B and C, so default values are 2 and 3 it is taking. Okay, if I pass 1 comma 6, 1 1 for A, I passed two values, so second value will be B, because this is a position based argument passing, and third value will be default value C. Now what I can also do is 1 comma C equals to 6, and when I do this, you will see first value I did not pass any keyword argument, so it will be treated as positional, so this will be assigned to A. Okay, and when I wrote C equals to 6, and that mean what it means, Python will assign 6 to C. Okay, and now there is no value I passed for B, so B will be used, means printed as 2, the default value. Okay, is it clear? So let's see how actually, what is the sequence, how Python decides when it gets some parameters. So steps that Python internally carries out to match arguments. So we'll see. First, assigns non-keyword argument by position. Okay. First, it will assign non-keyword arguments by position. We saw this. Then, assign keyword arguments by matching names. Then, this one. Okay. Then, extra non-keyword as this. So, we did not cover star name and star and double star. So, we'll see later on. And assign default values to unassigned arguments in header. First, it will assign all the positional arguments, then keyword arguments, and then default one. These two we'll see. After this, Python checks to make sure each argument is passed just one value. If not, an error is raised. When all matching is complete, Python assigns argument name to the objects passed to them. Okay. So once all this check is passed, then it will start assigning values to these local variables. Okay, and if it fails, any step it fails, if for example you have 3 and you pass 2 and you do not have this default one, okay, this will give error. See, this will give missing one required positional argument P, because I did not pass it here. Okay. Before assigning, all these things happen, and once everything is passed, it will assign all the local variables. Okay. Now we'll see what this star and double stars is. These are called arbitrary arguments. Okay. The first one is collecting arguments. When with this single star, where are the list? Where's that list? Yeah. Variable arguments collect arbitrary many positional or keyword arguments. When we use a star, it is a variable arguments collecting. We'll see how it is. If we have one function, this is the syntax for variable arguments in a function. When we use this star, Python start looking for the arguments list. Whatever number of argument you pass, it will collect those and pass it further. Okay. See, if we have empty, we are not passing anything. It's okay, it's printing empty. If I pass 2 and let's pass 2. Okay. See, it will take any argument, any number of argument and it will print. Yes, because we are only printing, so it is just printing. So this single argument, when this function is called, Python collects all the positional arguments into a new tuple, okay, and assigns the variable r's to that tuple. So whatever we are passing, we are passing as a positional. So it will assign to this. You see here, this args is a tuple. Okay, I remove this. It is treating it as a int. This is just I'm showing you. It's not this function can take any type of parameter. That polymorphic nature we saw already. So this is as a tuple. All the parameters are assigned as a tuple, and then inside this function we can do whatever we do on a tuple. We can do all those things. Means we can get all the values as we collect from this tuple. So that's why it's a collecting argument. We are collecting all the arguments as a tuple, and we are using it. Okay. Now the feature double star. Okay, double star, we saw this double star name, and what we call it is, it's a variable arguments unpacking. Pass arbitrary many positional or keyword assigned arguments. Okay, this is collecting and this is pass. So we'll see how this unpacking is. So how this goes is, we have this function which has double star, so it will unpack it here, and we pass two values to it. Okay, it will print, and it is printing it as a dictionary. Okay, so when we are using double star, all the values, all the parameters we are passing to this function, those will be collected as a dictionary. Okay, so it will be collected as a dictionary, key value pairs. Okay, is similar, but it only works for keyword arguments. It collects them into a new dictionary, which can then be processed with normal dictionary tools. Okay, so if I try to pass like this will give error. F takes 0 positional argument, but 2 were given. Okay, so it will not take, because we are using double star, it will not take positional argument. It will only collect your keyword based arguments. Okay, so you can see it is printing as a dictionary inside this function. Clear? Everyone, is it clear till now?
Yeah, Dheeraj.
Yeah.
Now let's move on. Let's see, if function head, we can combine normal argument, then star, then double star to give more flexibility to our function. Like this, we have one positional argument, then we have this p-args, then we have this k-args. Yes? K-arg is just a keyword based arguments, you can say. It's just a name, nothing else. And we pass it like this. Okay. So what our rule says, let's read it out again. First, it will check for non-keyword argument by position, then keyword argument by matching names, then assign extra non-keyword argument to star name tuple. Okay, this name is just a variable, so focus is remove this star. Okay, assign extra keyword argument. This is non-keyword argument, and this is keyword argument to double star dictionary. Then assign default values to unassigned argument in header. Okay, so what will happen here is, first it will check for positional. So one will be assigned to A. Okay, after that it checks for keyword. Okay, so we do not have any keyword based here argument. Keyword argument we do not have, because we do not have any other argument here. These are variable argument list. Okay, so it will assign 2 and 3 as a tuple to this P args. Then it is taking X and Y, and this will be assigned to K args. Let's see. So one is passed as a positional to A, then P args, it will collect these. This 2 and 3 will be passed as a tuple to PR, and this X and Y will be passed to K arg as a dictionary. Okay, so this is how these variable keywords, means variable parameters, we can pass to a function. So the basic difference is this will collect as a tuple, this will collect as a dictionary. Okay, this will be a keyword based parameter. It will take keyword based parameters, and this we can pass as a normal parameter. Okay, okay, so when we use star syntax, when we call a function, we can use the star syntax when we call a function. The inverse of its means in the function definition, it unpacks a collecting argument rather than building a collection of argument. Okay, so this is just what we discussed above. So it is, we are just creating it dynamically. Let's see, this PR, this is printing it as 1 2 3 4 here. Nothing. This is all we already discussed. Okay, so let's see, we have this function. Let's see different ways how Python will resolve. This will give more clarity. Do you guys want me to go through all variables, or you want to do it later on these examples? Because this will give a good clarity of how the variables arguments are unpacked. Let's try first one. So because we have this star here, okay, so this will, let's print it once. Everyone is printing 1 2 3 4 1 2 3 4. Okay, so this will be treated as a variable arg collecting. Is it collecting or unpacking? It's unpacking, I think. we are okay. Now we are collecting. Okay, that single star is called we are collecting. So what means is let me show something else. I showed it here is means here we have a normal position based argument, but we can pass as a uh, this variable argument list as a variable argument. So these will be unpacked here. Okay, and same in this case. Add divider here. Okay. What we are doing is we are creating an arg. Okay, dynamically means we are adding one dictionary we are creating and then we are passing it as a double star. Okay, so this will be printed as 1 2 3 4. This will be collected as a dictionary inside. Okay, for this positional based, and all A will be assigned 1, B will be assigned 2, like that it will be. Okay, and this is these are the examples. I think you guys do it by your own. Means I will upload all this code on GitHub. You try to execute all those 5 rules on this function. So this will give more clarity to you guys how the things are happening. Okay. Okay. So next is keyword only arguments. What these keyword only arguments are? So let's say we have this keyword only arguments are coded as named arguments that may appear after star args in the argument list. Okay. So after this, when we are using star, okay, whatever will be here, those will be treated collected as a keyword arguments only. We cannot pass positional argument after this star. Okay, so let's see. Here we are passing 1 2 3 4 and one keyword based argument. So one will be collected in A, 2 3 4 will be collected in B. See, 2 3 4 are collected as a tuple. Okay, and C is position keyword based. Okay, let's if I try to do this, this will give error. Missing one required keyword only argument, because first will be collected as A, and after that whatever it is coming, because star is used for variable arguments collection, so whatever is there it will be collected inside B, and we do not have any keyword based parameter here, so nothing is going to assign to C. Okay, so Python will give error for this kind of things. So just remember, we cannot pass any positional argument after star. Okay. We can also use a star character by itself in the argument list to indicate that a function does not accept a variable length argument list, but still expects all argument following the star to be passed as a keyword. What it means? It means if we pass star only, okay. So because we are not having any variable name here, so Python will assume that there is nothing like variable keywords I have to collect. But after this star, whatever we are passing means Python will assume whatever is coming, it should come as a keyword based. Okay, so this okay, let's try this. This one will be assigned in A, and then whatever we are passing, it will go to B and C. Okay. Let me add some subtitle here so it will be clear in output. One, two, three. Okay. And in any time, at any time, we can pass as a keyword base. Okay. But if we try to pass like this, okay. So this is positional based. This will give error. K only. This function takes one position argument and three were given. So it is treated as a position based, but actually this definition do not allow only one position based argument. Okay. So just remember, if we have only a star, if we have a star and then some name, variable name, all the variables will be collected in this variable. But when we have only star, it nothing will be collected in this, but whatever comes after that, it will come as a it should be passed as a keyword based. Okay. Hope it is clear till now. And we can still use default keywords. Okay. So if we can use default keywords here, and these are position. If we do not pass anything, it will print default values. If we pass anything, the past value will be used. Okay. Hope this is all clear. Now let me add a couple of points, important points. That keyword only argument must be specified after single star, not two. Named argument cannot appear after double star, arbitrary keyword form, and double star can't appear by itself in the argument list. Okay, so after double star, we cannot use named any other variable. Okay, we cannot have this kind of syntax. These are invalid syntax. Okay, so this means that in a function header, keyword only argument must be coded before double star arbitrary keyword form, and after after single star arbitrary positional form when both are passed. So if we have single star and double star both in our function, so these keyword only arguments should be passed after single star and before double star. Okay. Name appears whenever an argument name appears before single star, it is a possibly default positional argument, not keyword. So anything coming before single star will be positional argument. Okay, if it is not a specific keyword only, it will be a positional argument. So is it clear how this keyword base and these variable arguments are? Is there any question, query?
No, that it's good. At least for me.
Okay. There are some tips and advanced function things. Okay. So how to write a function? I'll just, these are not rules, but a guideline. Okay, to create a function. So you guys can read it out later on. Okay. I'll just show you an example for recursive function. Okay. How we can write a recursive function in our program. And let's see, we write one factorial. Okay. Okay, so it is same as that recursion is like calling itself again and again. Okay. So it's same. This concept, recursion concept, is same in all the languages, and there is nothing new in Python. It's just syntax. We have some syntax, and it will be same. Let's say we pass some number. So, and we want to build some factorial. Okay. It will print 2 because 2 is already. Now, let me introduce one function here. This is input. Whenever we want to take any input from user in Python, we have this input function. Okay. As to show anything on console to user, we have print. Same to get any input from user from console, we have this input function. This function will return a string. Okay, read a string from a standard input. The trailing new line is stripped. Okay, the prompt string, if given, is printed on a standard output without a trailing new line before reading input. Okay, so whatever will pass inside this function, this will be printed to user, and whatever user will enter, that will be assigned to this variable, and this will be collected as a string. So just remember, if you are collecting some integer value from user, so it will be collected as a string. So you will have to use int function to convert it into a integer. Now it is asking to pass some number. I'll pass 5. it's printed 120. Okay, so it's just a Fibonacci. So this is a recursion, and recursion can be nested. Okay, so let's see, we have this kind of list. Okay, if we have this kind of list where we don't know the depth of nesting, means what is the depth of these nested lists, when we don't know, because this recursive function we can write using if else and loops, for loops, while loops, using that, but it is difficult to iterate over this kind of list using loops, because we don't know the depth. This may be some different function. So let's write one function just to see. Okay. So this function, what it is doing is adding numbers, adding the total, doing total of this, whatever we are passing this list. Okay. And if we print this, these two. If we print, this will give the summation of all the elements in this list. Okay, let's pass it some different arbitrary, this kind of list. This will work. Sum all the values, but it is very difficult to write this function using for loops, simply for without recursion. Okay, it is difficult. So this is some place where we can prefer recursion over loops. Hope it is clear. Now let's see some properties of function objects. Okay. So as we saw in last session, that whenever we use def keyword, okay, it creates one function object. So function is also an object in Python, and whatever means it will have some attributes. That function will have some attributes. Okay, so this function will just print something, whatever we'll pass to it. Okay. So let's see what all attribute this function has. So we have this, we already saw this dir function, which shows all the attributes of the object in Python. Okay, let's see what all attributes this function object has. So it has these many attributes. Okay, so it's not like a function in other languages, it's an object and it will have attributes. So let's see couple of attributes. Let's see what this attribute. So this underscore, double underscore name, double score, this will give the name of the function. Okay, like that. If we use this double underscore code double underscore, this will give the location where this object is and the file name where this function is present and the line number 45. If you see, it's at line number 45 and the file name is advanced function.py. Okay, it will give you all the details. This code which we saw here, this is also an object and it will also have some attributes. You can see this underscore code also have some attributes. Okay, so it will have argument, cellware, code, cost, file name, file, different attributes it has. So let's see a couple of those. So this co-var names, this will give you the number of all the variable names which we have in this function. So in this echo function, we have one variable message. It is printing the name of the function, name of the argument. Okay, and same as this argument count, this will give a count of the argument. Okay, so these are default what we have in a function, okay, which Python provides us. But we can also add user-defined attributes to any function. So we have this echo, then using dot, and we can pass any name. Let's say num. Okay, num equals to 1. Let's print attributes, and you will see now this num is a attribute in this function. Okay, so we can add attributes into the function. We can add anything. This will also see num and doc. Okay, so these are like this. We can add attributes to the functions, and we can use default attributes of a function object. So this is all about advanced. These are some advanced things we can say of a function, advanced properties. Now there is another type of function which we call a lambda function. Okay, so let's see what it is. It's a function like we define any function as using def. Okay, this expression creates a function to be called later, but it returns the function instead of assigning it to a name. Okay, so this lambda function also creates one function object. Okay, but it returns that function instead of assigning it to a name. What this def do is, def creates one object, function object, and then assign that function object to a name, which we call function name. But in case of lambda, that assigning part that don't happen. Okay, this is why lambdas are sometimes called anonymous or unnamed function. Okay, they are often used as a way to inline function definition. So let's see some basics how the lambda functions are. So lambda generally form is a keyword lambda followed by one or more argument, okay, followed by the expression after colon. Okay, so it's a simple lambda, then number of arguments, whatever we want to pass have, and then one colon and then expression. Okay, lambda is an expression, not a statement. So means a lambda can appear in place. A def is not allowed by Python's syntax inside a list. We can pass it inside a list as a literal. Okay, a function calls argument. Lambda returns a value, a new function that can optionally be assigned to a name. Yes, we can assign that to a name. So when we'll assign it to a name, it will behave same as normal function we create using def. Okay. So lambda's body is a single expression, not a block of statements. Because it is limited to an expression, a lambda is less general than a def. Okay. You can only squeeze so much logic into a lambda body without using a statement such as if. Let's see. Apart from these, defs and lambda are sort of same. Okay, they do same kind of work. So let's compare. If we have this function and we are just adding these, okay, it will add these three values and return it. So we'll print it here. We can write same kind of function like this using lambda. Okay. In this case, this lambda function, this is behaving as a normal function because we are assigning it to a name. Okay. But this is the syntax, how we just syntax difference I want to show you. Okay. And like other normal functions, we can have default parameters also, default arguments into lambda function. We can use that. Okay. Say let's print it. Okay. So we passed one, so A is assigned to V, and then these two are just default. So why we should use lambda? Lambda comes in handy as a sort of function shorthand that allows you to embed a function within the code that uses it. Okay, means you need not to write another function. In the same line, you can write a lambda and you can use it. Okay. You don't have to go to somewhere else. You create a definition and then use that. Yeah. In the same line, you can do that same thing. If you have something like this simple one line statement you want to write. So for this, you need not to create a separate definition. Okay. You can directly use lambda here. Okay. In callbacks. So when we write a callback function, their lambdas are very helpful. Okay. Let's, for example, okay. So what this is a list of functions. Okay, lambda function, and we are calling lambda function from a list, and we are passing some argument. So if we print this, we see this. It is 9. Okay, it is given. If I want to write same code using def, okay, in that case I will have to create 3 different functions, okay, f1, f2, f3, and then add those into a list and then use this, call this. Okay, so instead of creating 3 different function at different place and assigning this, I can directly use lambda function and it will solve my problem. Okay, if you have some let's say simple condition, means lambdas you can use anywhere which are not very where you do not have to write a complex logic. If it's a straightforward thing, if else and all these things, so this is one way to write using def function, and same function you can write using lambda, okay, using this syntax like this: if this, else print this. So this ternary operator like this. Okay, and we can nest lambda function also, means we can write a lambda function inside a lambda function. So this action, this is a lambda function, and inside this lambda function I'm writing another lambda function. So when I'll call this function, okay, like this, so this 99 will be assigned to x, okay, and this lambda function will return another lambda function object, okay. So let me print this. See, 100. Okay, so it returned, sorry, this line, this is printed, and this is none because this function is not returning anything. That's why this line is printing none. Okay, so you got it right. We can nest into this. So this action, this function will return a new lambda function in this. Okay, and when I'll call act1, okay, so this is a call to this lambda function where 1 is assigned to y and it is adding x plus 1 and printing 100. Clear, right? And we don't have to assign any name to it. We can write same thing like this. There is no name assigned. We are not using any name. It's same. Okay, so this function will take 99 as a parameter, and after that this function will take 4 as a parameter and it will print it. Okay, so this is all about functions.